The next section of Chapter 11, Section 2, is what we call, what we're going to be dealing with, the area of sectors. So a sector is a section of a circle bounded by a central angle and its intercepted arc. Okay, so those are some words we haven't really heard yet. So way I like to think about it is think of it like a slice of pizza. So if you go to Casey's, you get a whole pizza and it's cut into like 8 pieces. Each of those pieces is what you would call a sector. So the central angle here is what we call x. Or actually, that's the degree of the arc, sorry. This is the arc. Right here. Okay? And x represents the degree measure of the arc. And then r is represents the radius of the circle you're dealing with. Okay? So the area of a sector of a circle is a portion of the entire area. So it's part of the whole area of a circle. So we use this formula. A equals x times pi r squared over 360. That's going to tell us the area of our slice of pizza. Okay? So let's try an example. Look at number 1. If BC is 16 feet, so BC is 16 feet. That's the radius. R equals 16. Okay. So our formula, area equals, and in this case, x equals 51. That's the degree of my arc, 51 degrees. So I'm just going to plug these values into my formula and solve. So x, 51, times pi, a little bit, times pi times 16 squared, all divided by 360. Okay. So I like to go ahead and combine the numbers with pi, but not including pi. So what I mean is I like to take 51 times 16 squared first. That gives us 13,056 times pi over 360. Okay. Then you're going to just have to put this in your calculator. The pi button is when you hit the blue second button. If you've got one of my fancy yellow calculators, you hit the blue second button, and then you'll see the little pi symbol above the caret. Most of the time that's where it is on calculators. Do not use 3.14. I want you to use the pi symbol. Okay? On some calculators it's different, but on all scientific calculators there is a pi symbol. So if you're having trouble finding the pi symbol, let me know. So then when I put this in my calculator, I end up with A equals 113.94, once it's to round to the nearest hundredth. 113.94, and then again I'm dealing with area, so since my radius is 16 feet, my units are feet squared. And that's it. Okay, so let's skip 3. 3 is the same. I want to look at number 5 because it's a little bit different. Okay, so notice how instead of being given my angle of my arc, the angle of my arc is all this whole thing right here. I can draw it in here. Because my sector is everything that's in gray. So I'm trying to find the area of all of this. Okay? Lucky for us, if you can remember, the degree of a circle is 360 degrees. So to find the degree of this arc, we would take 360 minus 42, and that's going to leave us 318 degrees. Okay, so that means this is 318. Let me get a different pen so we can see it. 318 degrees is the angle of my arc for my sector. So that means that is my x. And then my r, y, z is 9 inches. So that means my r is 9. And then same thing, I plug these into my formula. A equals 318 times pi times 9 squared, all over 360. Okay, so I need to plug that into my calculator. I end up with A equals 25,758 pi over 360, which equals 224.78 inches squared, because my units are inches. Okay, and so there's my area of this gray sector here, all of that. Okay, so that's what we're doing here. That's what you're doing on 1 through 7. Yeah. No, 1 through, let me see here. Yeah, 1 through 7. Or 10. God, I can't talk. 1 through 10. This is all you're doing. You're identifying what the x is, what the r is, plugging those into this equation up here. This is also on your reference sheet that I gave out. It's like on the bottom. It might be like the very last one. I can't remember for sure. So it is also on your reference sheet, this formula. Okay. So you'll need to finish 1 through 10. Then I want to look at 11 through 16. So 11 through 16 are kind of, they're a little bit different. In this case, we're trying to find the area of the total area of the shaded region, and then round to the nearest hundredth. So in this case, I have 2 sectors. If I'm looking at number 11, I have 2 sectors here I need to find the area of. Okay. Well, if you notice, these lines are straight lines. So that makes these angles vertical angles, so they're congruent. So this is also 46 degrees. Okay. So you can, in turn, you can find the area of this one and then the area of this one and add those together, or we can use our area formula and just combine these 2 angles together. So what that means is, that would mean x is equal to 2 times 46, which is 92. Okay, so that's what my x is going to be. Since I've got 2 sections and they have the same angle, that's what my x is going to be. That's my degree of the arc, the total arc. I have 2 arcs at 46 degrees. So when I combine those together, it's a 92 degree arc total. Okay. And then my radius is still, let's see, HG is 7 centimeters. Okay. Since my radius is the same all around, the radius on both is still 7 centimeters. So R equals 7. So if I put all this in my formula, A equals 92 pi times 7 squared over 360. And then I solve. So A equals 4,508 pi over 360. So then my area equals 39.34 centimeters squared. And that's it. So as long as your sectors have the same, well, it doesn't really matter. When you are discovering the shaded region, the total area of a shaded region, you need to add together your degree of arcs. Okay? You could think of it as like if I didn't have this here, let me try to erase this here. If I didn't have my sector here, let's try to write this out here. If instead of being here, it was over here, and it was 46 degrees. Then I would be finding the area of this sector, which is 46 and 46, which is 92 degrees. So you can think of it like that. You think about you're putting the two shaded regions together on the circle. Okay, so let's look at, I don't want to look at 13. We can just glance at 15 real quick. Okay, so this one's a little bit different. I don't have vertical angles. I don't even have a degree angle for this one here. However, this is a straight line. So that makes this a 180 degree angle. Okay. And then JM, this whole thing equals 10. So when the diameter is 10, remember the radius is half of that. So that makes my radius 5 millimeters. Okay? So again, since the radius is the same all around, nothing changes there. But just like up on number 11, we combine the two arc degrees together. So 180 plus 58 is going to give me 238. And then I plug that into my equation. A equals 238 times pi times 5 squared all over 360. And then you complete and solve. Okay. So when you're finding the area of shaded regions, when you're dealing with sectors, if you have more than one, you combine the two arc degrees together and then plug that in for x in your formula. That becomes your x. Okay, so I will let you guys finish the rest of these up. You'll have to finish 15 and then do 2, 3, 4, 6, and 7 through 10, 12, 13, 14, 15, and 16. So finish those up for class and then be prepared with some questions if you're going to have them.